So now that we've got this whole 68, 95, almost all thing, let's go ahead and talk about how it applies. Now, when I want to tell you something fits normal distribution, I could write down that it is, in fact, normally distributed. Or I could write it shorthand. So, for instance, we're going to be talking about SAT scores. SAT is a standardized test. Notice we say standardized, and it's actually designed to be normally distributed. So when I write that down here, I'm going to go ahead and write the SAT is approximately normally distributed. So when I write this out, this little symbol here means approximately. That is, it's not going to meet these standards exactly, but it's roughly that. This N means it's normally distributed. It meets the 68 and 95 almost all. It's unimodal and symmetric. And it's a little shorter to write it out that way than to write it's approximately normally distributed. I can also put all the information in here. That is, I can tell you the average on the SAT is about 1,500. This is for the entire test, if you take all three things and add them up. And the standard deviation is about 350. So once again, here I have my average. And here I have my standard deviation. And once again, this is for all three tests combined. So what I'm going to do is I'm going to go ahead and put all that information over here. To do that, we're going to talk about what the average person will score. And right away, I can tell the average person is going to score right around a 1,500. So that is the average. That's the center value. That is if I surveyed everyone and made a histogram, the highest bar on the histogram would be the center there with 1,500, because it's the average score. And it's symmetric and unimodal. Now what I'm going to do is I'm going to go ahead and take that, and I'm going to go one standard deviation on either side. So I'm going to take my center measurement, and I'm going to add one standard deviation, and I'm going to take my center measurement, and I'm going to subtract off one standard deviation. Doing that, I'll go ahead and I'll take 1,500 and add 250. So my center measurement, 1,500 plus 250. And then 1,500 minus 250. And when I do that, I'll get this measurement out here, which is 1,750, and this one over here, which is 1,250. And what this tells me, because SAT is standardized, it's designed to have a normal distribution, is that if I look at this center percentage here, in between, that there is actually 68% of all test takers there. That is, 68% of everyone on the SAT will be between 1,250 and 1,750 when they get their scores back. So I've got 68% in the center there. Let's go ahead and go one more standard deviation on either side. That is, I'm going to move out to here. And this will be like the center plus 2 standard deviations. And this will be like the center minus 2 standard deviations. Now, I do want to point out that I'm abbreviating there, so STDEV, standard deviation. To get that value, I'd go ahead and I'd take my 1,500, my average, and I'd add 2 times 250. And over on this side, I'd take my average of 1,500, and I'd subtract off 2 times 250. So doing that, on the upper end here, I'll get 2,000, and on the lower end, I'll get 1,000. And what this is telling me is that 95% of everyone on the SAT will get a score between 1,000 and 2,000. Finally, we can go ahead and go 3 standard deviations out. This is like taking the center plus 3 times my standard deviation, and then over here the center minus 3 times my standard deviation. And when I do this, plugging in the numbers, this one right here will be 1,500 plus 3 times 250, and this one right here will be 1,500 minus 3 times 250. These will give me values of 2,250 and 750, and what this is going to tell me is that almost everyone on the SAT will get between a 750 and a 2,250 on there. This also tells us something else. That is, if you go in and score somehow miraculously a 500 on the SAT overall, we'd consider you to be an outlier, because you would be more than 3 standard deviations away from the center. Or if you went in and somehow scored, let's say, at 2,400. Think about it for a second. That would also be really, really weird, right? So once again, once we know something is normally distributed, we can go ahead and say, well, one standard deviation out on either side gives us the middle 68% of people. 2 standard deviations out on either side give us the middle 95% of everyone. And then if we go ahead and we go 3 standard deviations out, this will be almost all. And in addition, with the normal distribution, we can say anyone under that is anyone under a 750, or anyone above that, above a 2250, could be considered a potential outlier.